Okay, so we have to set up basically parameters that are going to subdivide this rectangle into points. And ideally, the points are going to match or be correlative to the image resolution or image size. So let me just give myself a little bit more room here. We're going to need it. But I want to be sure, the first step here that I just kind of want to warn you about is when you're setting up a domain to put points in a space, you typically want to ensure that you're not going to have your geometry go beyond the boundary. So what I'm going to do in this case is actually reduce the the range, I guess you would say, of where these points can fall to 5 whatever units, feet, inches, or in this case 5 pixels from the edge of the image. Okay, so that's just going to be my benchmark to start. So to do that, I know I need to construct a domain in the x and the y axis, or you don't know, but I'm telling you, we need to construct both of these domains. So I'm going to drop in under math and domain, construct domain. And to give you a sense of how we're going to relate this, we are going to relate this by assigning domain information into points. Okay, so I'm giving you sort of the all-around approach to how you might begin thinking about this, because I know I want to put curves on points. I want to subdivide the rectangle into rows of points that I can put the circles on. So I'll just drop it in now, thinking ahead. So I'm going to go to point and construct point. Okay, I'll put it over here. So I've got to get the constructed domain to speak to these points. But first, let me actually just create that numerical boundary. So I've got essentially a domain that's going to read from something to something. So if my image is 500 pixels wide, and I want to only use the pixels that are within, or that are inwards of 5 pixels on either side, then my domain will be what?
495?
On one end, yeah, it'll be 495, yes. But that's the end. Remember, we have a linear relationship here, reading from the x origin. 5, right? So we're going to start from 5, and we're going to end at 495. So we could do it simply by dropping in either a number or an integer. For the lower domain, I'm going to drop in an integer. So I'm going to say set integer. I'm going to make it 5. Actually, let me just use a panel. And then because I might change my image later on, I'm actually going to create a mathematical relationship to the 500 for my endpoint domain. So I'm going to go up into math, and I'm going to say minus, and it's going to be minus 5. So 500 minus 5 will go into B. So now we're reading our domain defined value is 5 to 495. What questions do you have about that? Yes?
Why did you have to do the equation?
Just in case I change my number. Because the 5, what I'm making a decision right now. Like, I know, I'm suspecting that I will not change the number 5 around the perimeter.
Mm-hmm.
So 5 is static,
Mm-hmm.
but I might change the image, in which case I want it to just, change by the pixel count, and I could just change the pixel count once. Okay, so on the same note, I'm going to copy and paste this down, except I'm going to replace the connection that is 500 into the mathematical operator with 579. So this domain is reading 5 to 495, while the next domain is going to read from 5 to 574. Is that clear enough? So let me pause here while you get caught up on that, and I'll troubleshoot, and then we'll move on. All right, and our next step is going to be to establish a range of numbers. And range is found, I believe it's under set, sequence, range. So when we, range is going to ask for a domain and a number or a count of numbers, essentially. So we've got, this is under set, sequence. We're going to plug the first one in here. And for my numbers, I'm going to make a slider from 0 to 100. We'll discuss why later, I guess. But let's take a look at what that actually looks like. So I'm just dropping in a panel so we can see what the output is. Right now, the output is an empty number parameter because for the number of steps that we've generated, it says 0. So if I create a range, it's going to go from, let's say it's 2 steps, meaning it's 2 subdivisions, so 3 points. It'll go from 5 to somewhere in between 5 to our maximum domain, right? So we've got 5, we've got somewhere in between 5 and 495, which is 250, so exactly half, and 495, which is our maximum. So as you continue to expand the list, it does the same thing. It just generates numbers that are of a scalar proportional relationship from your minimum to your maximum boundary domain values. Okay, so I'll leave that there just so you can kind of see it. And we're going to do the same thing for the other domain. And we can bump these numbers up quite a bit, actually.
Could you also do the same thing with divide domain? Or would that give you a different kind of result?
That's a fair question. Divide domain is actually going to... let me see what the data output is for that. So if I put that in, it's going to ask for a number of segments, 10. Ah, right. So that gives you a subdivision of individual domains. That's right. So see how this one is reading 0 to 0.5, 0.5 to 1. So rather than just giving you the numerical instance subdivision between the domain minimum and maximum, this one is actually taking your domain and subdividing it into smaller domains. So the next step for us is really to get these 2 lists to speak to one another. So let me just drop another panel in over here, and they're going to look like different lists, right? So if I have this one at like 47 and that one's at 27, the numbers are going to be a little bit different. These numbers are correlative to how many pixels you have. You'll see when we start playing with it that it actually kind of looks like old school TVs. If your antenna was messed up, you could see the image kind of scrolling. You'll kind of get a sense of that when we start playing around with this, but I'll leave them up there for you to see the data outputs anyway. But we're not going to actually plug anything through those. So what we want is essentially a grid. Okay, so we're going to go into, sorry, not a grid. We're going to create a relationship from one list of points to the other. So it's matrix-like, but it's not quite a matrix. That's probably just confusing you. Strike that from the record, guys. So we're going to do cross-reference, okay? We're going to cross-reference these lists. Okay, that's the easy way of explaining it. So cross-reference is under sets and list. And so it's going to ask you, obviously, for lists to cross-reference. And notice how this is one that you can add multiple instances to, so we can cross-reference as many lists as we want. So I'll plug in the first list to A, and the second list to B. And what it's going to give me here is a relationship between the two. So, for instance, the A list is reading 5 and 23 and 41 and 59, so on and so forth. And the B list is reading, actually, why are there 1,300 of those? 48, 48, 48. 48 times 28, this one. I'm a little confused why there's that many of them. So, oh, right, okay, so this is not a flattened list, so it's going to give you as many subdivisions, so I guess we'll have 27 subdivisions of the first index and then 27 of the next, so on and so forth. That's why there's 55 of them. So, yeah, that's why. Okay. So then the really interesting part is how this relates to the grid. Okay, so essentially if we establish our x and our y to be these numerical inputs, then it's going to give us a grid across this surface that has the proper domain. So this is like the long version of just establishing that range domain that we did. Sorry, not domain. The construct domain that we did to reduce the range of an overall surface. So we'll plug the A into X and see how it's starting to do your subdivisions across the X value. And the B goes into Y.
And are we doing the long version just for learning?
For maximum flexibility. Yeah. And for learning, generally speaking. So now we can actually redefine how many steps are in each one of these ranges to give us a different resolution along the X and the Y axis, right? So I can increase or decrease the number of subdivisions on either side. Okay, so these two actually do have a relationship to one another, but we'll get into that once we actually plug it in to the image and create our pixels. Okay, so what questions do you have so far? Okay.